Okay, this is the start of the big one. So this is going to be the enemy's brain, basically. This is going to determine whether the enemy can see us and then dictate whether it's going to fire at us or if it's just going to carry on with its patrol. So this is quite a big one, to the point that I've written my own notes out even. I'm not just coding this now. It's got serious. So we are going to need some script. Let's go to scripts and let's create a C# script. And I'm going to call mine enemy AI because it is the artificial intelligence, the brain of the enemy, but you can call it vision, line of sight, whatever you want it to be. I'm going to call it enemy AI and I'm going to boot it up. There we go. Good news, we can get rid of something. We don't need a start function. We're not going to do anything too specific when this script begins, but we do need to remember some things. We need to know the target. So obviously this enemy needs to be looking for something. We need it to know its view angle, its field of view, I guess you could call it, or the cone angle. I'm going to call it view angle there. And we also need to know its range, so how far can it actually see. And I'm going to call this, let's say, view distance. These aren't actual variable names, they're just little points of what we need to know. And then in terms of what this object can do, it's going to need to be able to check for line of sight. So make sure there's nothing in the way. So we're going to need to check line of sight, not line renderer of sight, just line of sight will do. It's also going to need to check the cone of sight to make sure that the angle that you're looking at is within its viewable range. So let's say check cone, check network connection. I should just stop bothering writing these. Check cone angle. There we go. And it's also going to need to react to whether it can see you or not. So it's going to need a basic kind of normal behavior and a one for when it can see you. So let's have a normal behavior function and a chasing behavior. Okay. So a bunch of things really. Let's start with the variables. So this target is going to be a game object. So let's make that a public game object and we will call it search target. Sounds right, and it's what I've got in my notes, so it's got to be good. Call it search target. So that's going to be the object, i.e. the player, that this enemy is looking for every frame. We then need this viewing angle, and let's make that public again so we can change it from outside. We can customize the enemies, and let's call it, well, let's make it a float, public float cone angle. And then finally we need the view distance, so this can be a public float again, and let's call it view distance. View distance, okay. And we should probably set defaults for those. So the cone angle by default I'm going to say 60 degrees, and the view distance by default I'm going to say 5 units. Why not? Okay, so far so good, I hope. Let's set up these functions as well. These two are a bit different, so I'm going to do them after. So normal behavior is dead straightforward. So let's just go void normal behavior. So that's going to be a function that we use when the enemy's just going about its normal business when it can't see us. And then chasing behavior is going to be the function that we use when the enemy can see us, when it wants to shoot at us, for example, or run after us, whatever you want it to do. So two functions set up. Now these ones are going to be slightly different. So check line of sight, check cone angle, they actually need to give us a response. They need to tell us if they've succeeded or failed. So we're going to do away with the void this time. We're going to ask them for a bit of information back. So in the case of both of them, we want a Boolean returned to us. So these are going to be bools. So for the line of sight, we want a bool. We want a true or a false when we check line of sight. So we're going to have a function that actually gives us some information back. And by default, I'm just going to, for now, put a placeholder in that returns false. So by default, for now, it can't see us. It can never see us. It's always false. Then we're going to have a similar setup for the cone angle. So I'm going to have bool check target in cone. And again, that's going to just return false by default. So as it stands, the enemy definitely cannot see us, and it doesn't even react when it can. I think what we'll do, just again as placeholders, so we've got placeholders for those two. In the normal behavior, let's just do a quick debug.log to the console to say I am behaving normally. I'm behaving normally. And I'm going to copy that. I'm going to try to copy that, paste it into the chasing, and here I'm going to say I'm giving chase. Okay. So by no means finished, but we at least have those functions set up. We then need the logic, which is going to go in our update function. So the update function is going to determine whether this object can see the player and then call the right function out of these two dependent on the situation. And for the sake of this video, we're just going to focus on the line of sight first, because I'll need a break. This one's taking a while. So for now, the update function is just going to be concerned over whether we have direct line of sight. We're not going to worry about the cone in the first instance. So the first step is to actually use that check line of sight function to see if the player has line of sight from the enemy. So we're going to store this answer in a boolean. So we're going to store either true or false in our update function, and let's call it insight. And that's going to equal our function. We're going to call our function, so we're going to check line of sight with brackets after it, and the answer, the boolean that it returns, is going to be chucked into this variable. Okay. And then we can react to that, can't we? So we can have an if statement directly after it saying if brackets insight. And we could actually flesh it out if we wanted to by asking if that's true. But you don't actually need to do that because insight has to be either true or false. So we're asking if true is true or if true is false. We could just say if insight, and that would say if true or if false. So the answer would be true or false either way. We don't need to check that true is true, if you get me. So we can just use if insight. So if it is insight, we want to do our chasing behavior. And then close the curly brackets for that if and add an else. So if it's not insight, we want to do our normal behavior. And that is the logic for now, at least, set up in the update function. So we use our check line of sight function, we store its result in a boolean, we ask if the answer was yes. If it was yes, we're going to chase, otherwise we're going to do our normal stuff. And because the current setup means that we never see the player, we should always be doing our normal behavior. So I'm going to save that for now, go to Unity, I'm just going to work on one enemy for now so we don't get clashing messages. And I'm going to put the enemy AI function onto that enemy. And we do need to set a search target. So I'm going to drag my player into that search target, and I'm going to hit play and hope. And you can see down at the bottom, my console is saying I am behaving normally. That's actually being spammed lots of times. It's happening in every frame, and will never change because there is no way for that enemy to currently see me because we've not done the line of sight logic. So that's what we're actually going to do next. Okay, and this is very specific to Unity. All of the code we're about to do is very particular, very specific to Unity's physics system, and we're going to do it all in the check line of sight function. So find your line of sight function, and we're going to embellish this a little bit. So the inevitable result, the end result that we're always going to leave there is that the enemy can't see us. So that's always going to be the last line of this function. If we ever get to that line of sight, that line of code, it means that the enemy doesn't have line of sight to us. Above that, we're going to do all the logic to check if it can see us. And we're going to start by figuring out the direction from the enemy to us, which is very similar to the way we did the facing direction. It is that triangle set up again, except it's from the enemy to us this time. So let's make a vector 2, because we're using the 2D physics engine. We're going to try and keep everything in 2D if possible. And let's call this target vector. So this is going to be a vector from the enemy to us, which means it's going to be our search target dot transform dot position minus the enemy's position. And since this code is on the enemy, that means just transform dot position. So that is our target vector. That's a vector from the enemy to the target, which means we can then set up an array. An array is an imaginary line, not to be confused with an array, which is a list. We're casting a ray, which is an imaginary line beamed out from a position to see if it hits anything. So we're going to store a raycast hit. Raycast hit 2D, because we're using the 2D physics engine. And we're going to call it hit. So we're going to beam a ray. If that ray hits anything, it will store it into this variable. So we're going to blast a ray from the enemy and store it into this hit variable. So raycast hit 2D, hit equals, and then we use the physics system. So we go physics 2D dot raycast. So this is the function that actually blasts out a ray from a specific position in a certain direction. So the position we want to use is this enemy's position. So transform.position is where we want the ray to originate from. And then the target vector is what we've just figured out. So that's the direction we want to use. And then finally, we want to set a distance as well. So we're actually using option 2 of 5 out of this raycast function. And we want to use our view distance. We've stored it up there. So we're going to make sure that the ray is never longer than our line of sight, of our view distance, sorry. And there we go. So that line's finished. That will blast a ray. If the ray hits anything, there'll be all sorts of data stored inside this hit variable. So we're now going to query that. So we're going to say if, and then brackets. And this is where we can ask if the raycast actually hit something by going if hit dot collider. And that simply just asks if a collider was hit. Does a collider exist on the end of this ray? But we're not just looking for any collider. We don't want to react to hitting a wall. The enemy's quite often going to be able to see a wall. So we're going to use an AND here. So 2 ampersands lets us specify an extra question. So if the collider exists and the collider's game object is our search target. So if the game object that collider is part of is the object that we were looking for in the first place, it means that we have actually cast a ray directly into our target, which means we can return true because we've seen the object we're after. So there's seemingly very few lines of code there, but there is a lot going on. So the first line, just to recap, figures out the vector from the enemy towards the player. The second line does the bulk of the work. So this stores some information about a raycast hit. So if a ray has hit an object, this is populated with all sorts of information. But to actually figure that out, we use the 2D physics system to cast a ray, an imaginary line, from our enemy's position along that target vector direction and based on the distance that we're allowing this enemy to see. Then we ask if that raycast hit anything, so we ask if there was a collider, and if so, if there was a collider, was that collider part of our search target? If so, that means we've found the object we were looking for, so we return true. And then if none of that ever happened, if this if didn't happen, we return false. And that now has everything set up for this update logic to work. So the function there, the check line of sight, does all the work. This boolean stores a true or a false for whether we've been seen or not, and then this if statement reacts accordingly. So let's save that, jump to Unity, and let's watch it all go hideously wrong when I hit the play button. So it's behaving normally. When I pop out, you'll notice it's still behaving normally, even though it clearly does have line of sight to us. And that's not because the code's wrong, for once. It's because there's just an extra little oddity to the physics system that means the enemy's actually seeing itself. That was weird, it just fired through the wall. Okay, so the code's fine, but the enemy, because the ray goes out from the center of the enemy, it actually just hits itself. So we're going to disable that because for whatever reason that's on by default. So we're going to go to Edit again, we've done this earlier, Project Settings, Physics 2D. And there's a little tick box that says Queries Start in Colliders, which means collision tests or ray casts start within the collider that they were spawned in, which is just stupid. So we're going to turn that off. And then we're going to hit play. And we're going to run into line of sight without getting shot. And you can see down at the bottom now it's saying I am giving chase. So the enemy does have line of sight towards me, which is perfect. And it's something we can build on. So we could affect the movement and the firing of the enemy once that's the case. But I'm going to take a break there and split this into a couple of videos because there's a lot going on.